Alright, and welcome to cubic transformations. Now, in number 1, we're given f of x is equal to x minus 1 cubed plus 1 is transformed to g of x is equal to 1 half x plus 2 cubed plus 2. Okay, so kind of like in our last video, we're going to use f of x in orange, and the first thing that you always want to do is find the vertex. In this nice blue color, we're going to write g of x. We're going to go ahead and find that vertex as well. Now, finding the vertex is essentially the same. You look inside the function, or at the grouping, x minus 1 is equal to 0. We'll add 1 to both sides, and of course x is equal to 1. So our vertex is at 1, comma, look out here, we have that plus 1. Alright, I'll write my 1's the same way, I guess. And that's our h, comma, k. That is our vertex. We go to the right 1, up 1. And this is a cubic function. This is what a cubic function looks like. It goes up, and it curves into the point of inflection, and then it curves up again. Alright? Now let's go ahead and look at g of x. G of x. Here, inside of our grouping, we have x plus 2, which we set equal to 0. To get x by itself, we'll subtract 2 from both sides, and x is equal to negative 2. Our vertex is at negative 2, comma, positive 2. That is our h, comma, k. Okay, so I go to the left 2, and I go up 2, and we're right here. Now notice we have this 1 half, and since a is 1 half, since a is less than 1, that actually means that we're going to vertically compress this function, and so it'll actually be a little bit wider. Just kind of like that. Okay? Alright, so let's describe the transformation. Well, from f of x to g of x, we went to the left 1, 2, 3. So we went left 3. You'll always kind of count the vertex to the vertex. We went up 1, and they're both positive a values, so there's no reflection. And we went from 1 to 1 half. Since a decreased, we actually have a vertical compression. Since a decreased, we have a vertical compression. Now, let's go ahead and write our rule. And so I'd encourage you to pause the video, finish taking your notes, and then let's clean this up just a little bit. Okay, in order to answer part B, it says write the rule transforming f of x to g of x. Remember, we always write our second function on top, second function, and we write our first function on bottom. And what we can do is always start by looking at the a term. Remember, when you don't see an a term, it's assumed to be 1. Okay, so for our a term, I take g of x, which is 1 half's a term, and I divide it by f of x a term, which is 1. Remember, dividing by 1 doesn't change anything, so 1 half divided by 1 is 1 half. Or we could say a is equal to 1 half. Here in the middle, this is where we find our h value, or actually I should really be calling it negative h. That's okay. And for this one, remember what you want to do is take the g of x value, 2, and we want to subtract the f of x value, negative 1. Well, remember, 2 negatives make a positive, and 2 plus 1 is 3. Now remember, that's not necessarily h. Okay, and then here in our k value, well, we have a 2, a positive 2. We subtract the f of x k value, minus 1, and 2 minus 1 is 1. So what does this look like? Well, our rule in transforming f of x to g of x can be written as g of x is equal to 1 half f of, so that's showing us that f is being transformed to g, 1 half f of x plus 3, so that's where that positive 3 goes, and then here we put our plus 1. And let's kind of recap, does this match up? The 1 half is vertically compressing f of x. This x plus 3 is of course shifting us to the left 3, and this plus 1 is shifting us up 1, so our rule checks out with what we see on the graph. Alright, let's move to our second example. Okay, here we have example number 2. Now here we have the function f of x equals negative 2 x plus 1 cubed plus 4. So let's go ahead and find our vertex first. Remember, we look inside the function at our grouping, x plus 1. We can set that equal to 0. And to get x by itself, we'll subtract 1 from both sides. And we get the x value of our vertex is, is negative 1, comma, and our k value is that positive 4. Now remember, we always label the vertex h comma k. All right, so we go to the left 1 and up 1, 2, 3, 4. Put our graph. Now this is interesting because our a value is negative. There's actually, this is already being reflected over the xy axis. So instead of going up from the left to the right, now from the left to right, it actually goes down. And this positive 2 means that our graph is going to be vertically stretched. Okay? All right, now let's go ahead and take a look at g of x. Okay, so g of x, we have our grouping is x plus 2. So I can write x plus 2 is equal to 0. We'll subtract 2 from both sides, and x is equal to negative 2. So our vertex is at negative 2 comma positive 1. Now from here, of course, this is our h comma k. And we can go to the left 2 and up 1. But notice here our a value is positive and it's a 4. So this is going to be vertically stretched even further. But since it's positive, we start going up from the left. We flip and then we go up to the right. But you just have to draw that about twice as narrow as the original function. Okay, so just kind of looking at this, let's talk about our transformations. Okay, it looks like it went 1 unit to the left. So we can say 1 left. It looks like it went, from where I'm sitting at, it went 3 units up. So 1, 2, 3. So we can say, oh, that's weird, I wrote it out. Oh well, 3 up. And since it went from a positive 2 to a positive 4, since a increased, we know we had a vertical stretch. And also, since we went from a negative to a positive, we know that we also had a reflection. Okay, now that is how we can tell from just simply graphing it and looking at it. Let's go ahead and clean this up, and let's see if we can come to our rule by looking at both functions. Okie doke, so I cleaned things up, and I also noticed that I made a very silly mistake. Remember, we're going from f of x to g of x, and remember I started this out by saying, hey, we went 1 unit to the left. Well, notice from this vertex, when we go 1 unit to the left, we're then going down 1, 2, 3, not up. And so that's my mistake right there. This shouldn't be 3 up, it should have been 3 down. Alright, so y'all have my apologies. Go ahead, change your notes. From this orange vertex to this blue vertex, we went to the left 1 and then 3 down. My apologies, guys. Okay, now, the way that I caught that, I'll kind of illustrate that here in just a moment. But it was when I was looking at this. So let's kind of split this up. So we can go ahead and write our a value, we can write our h value, and we can write our k value. Remember, we get our a value for the transformation for the rule by dividing our two a values. So this is the first time where we'll have a non-1 number. We'll do 4 divided by negative 2, and we'll get negative 2. So a is equal to negative 2 for the rule. Now here for h, we have a positive 2 minus a positive 1, which gives us a positive 1. And here we have a 1 minus a positive 4, which is really negative 3. So let's go ahead and write our rule. We're going to write g of x is equal to the a value of the rule, negative 2f. Remember, this is the rule telling us how to transform f to g, x plus 1, so this is the number that we write right here, and then minus 3. And let's go ahead and see if this rule now matches up with our description. We have this negative symbol, which means that there was a reflection. We have a positive 2, we have the 2, which is greater than 1, so there was a vertical stretch. That checks out. We have x plus 1, which means that x is truly negative 1, which means we went 1 to the left, check. And we have this minus 3, which means that we went 3 down. And so when I was seeing the 1 went to a 4, that's where I realized that I had made a mistake. The 4 had gone to a 1. Okay, well guys, here's our rule, here's the correct description, and I hope that this helps. I'll catch you guys in our next video.